In order to get CPM running on my Z80 computer, I first of all needed to get it running in my emulator for my Z80 computer. So in this video, I'm going to actually show the CPM actually running in my emulator for my Z80 computer. And I'll demonstrate some of the features of CPM, and then I'll demonstrate the assembler in CPM and Microsoft Basic in CPM. But in a future video, I'll actually show how to actually get CPM up and running on the Z80 computer, and another video I'll show it actually running on my Z80 computer in its a physical form. So this is my the menu which I get with when I start up my computer, and some of these menu items I've already gone over in previous videos, actually running on my physical computer. But this option F6 is for starting CPM. So if I hit F6, and it actually goes straight into CPM on my computer. If I do a directory, these are the system files. Many of them come with CPM, and there's some extra ones in here. I'll give credit to where all of this came from as well. When I actually got it running, I actually use a different approach to a lot of people. So I'll explain all that in the next video. But to go over some of these system files, if you type ls, it's a different version of a directory, and it gives it a bit more explanation as to what the files are and how big each file is and things. And there's also a program on here called survey. When you run that, it searches the actual system and tells you about CPM running on your system. So at the top here, it tells me about the drive which I've got currently logged in, and it tells me how much free space there is, and it tells me about the memory map, and these T's are the transient program area, and this version of CPM has been built for 56K. So the top of CPM up here is at the 56K boundary. Then these B's below the 56K boundary are the BIOS for CPM, and then the CCP and BDOS are in the C's which are below that, and then my system BIOS are the B's above that as well. And that's how it was actually built when I actually got this version of CPM, and that just fits in perfectly because it gives me 2K free in my BIOS where I can expand it for future stuff. And it gives some other information about CPM below, like whether the entry address points for the BIOS and the BDOS. So it says how much RAM there is, how big the biggest transient program is, but you can also overwrite some of the CPM programs as well. And also somehow it's managed to find out what my active I/O ports are. I'm guessing it's probably just searched for I/O ports which don't give a result of FF. I guess that's how it's done that, I don't know. But so that's my system drive, but I've got about 8 drives on my computer, but on drive C is where I have my development stuff. But if you see, there's only one file on here, so if I type that, it tells me about how the drive is laid out. So in CPM 2.2 there are no directory structures, but you do have users, and you can put different files in different users, so you can separate things out. That's what I've used here. So under user 2 I've got the assembly source code stuff, and under user 1 I've got the Microsoft Basic stuff. So if I go into user 2 and now I do a directory, it shows me the assembly stuff. So I've got a simple assembly program here, and if I go A : for the system commands, and WM for, I think it's word master, and I'll show you my assembly program. This is just example one, which I've created just to do some do some example 8080 assembly. So even though this is it's running on my Z80 computer, it's the actual assembler that comes with CPM is an 8080 assembler, and you put your code at address 100 hex because all CPM programs start there. And then I've just got some examples of calling BDOS routine. So when you call BDOS routine, it's you call the address 05, and you set up your arguments prior to that. So you need to set up in C the actual function you want to call within BDOS, and then your argument's going to E and E and D, the DE register. So this just goes through a loop of all the characters from character 32, which is this 20 hex, and it displays all the characters on the display. And then I call some other BDOS functions down here, and this displays a message, which I'll show you the definition of the message, which is further down in this assembly code. And again, it just calls a BDOS function to display a string. And then it calls a BDOS function to wait for a key press, and it'll return to CPM after it's got that key press. Now in WordMaster is a really good a page editor for doing things like assembly programming. If you go Control J, that's all you need to remember, because when you type Control J, it gives you the help file for WordMaster. And then you can go Control J to get the next page, or you can hit any other key to return to your document. And if you go Control C, it goes down the page. So this is the end of my program, and it just shows you the message that I've defined there. So if I hit Escape and then Q to quit, because I'm not going to save any changes, I come back to CPM. Now to assemble that program, I need to type ASM which is the assembler, and then just the start of the file name. You don't need to put the .asm, and it will then pick up the charset.asm file, and it will assemble it, and it creates a couple of files. It creates a charset.prn, which is the output of the actual assembler, and just to give you details of what it's done, and it creates a hex file as well. It doesn't create an actual executable at this stage. So if when it comes back to the command prompt, I type the charset.prm file. So this is the output of what the assembler did, and you can see the address and the actual bytecode, machine code, which it actually produced, and you can see the data as well. And then the hex file. So that's and it produces an Intel standard hex file. And in order to create a COM file, which is the executor file, you have to type use the command load and pass it the hex file. That then reads in the hex file and produces a .com file, which is the actual executor file. And then, so once that's done that, I can actually type at the command line the actual charset program, which is now been created, and it runs, and it displays the character sets from 32, which is the space character at the very start. And then there's the message. It's it's printed when I call that BDOS function to print a message, and it's waiting for me to press a key. So if I press any key, it just returns me back to the CCP console for CPM. So that's the assembler. Now I'll go through the Microsoft Basic stuff, which I think I would put in user 1. So there's some basic stuff, and if I type ASM MBASIC, and if you can either hit return here and it just goes into MBASIC at the command prompt, or you can type a program you want to run. So I've got a charset.bas program. I hit return. MBASIC's about a bit over 20k in size, so it takes a little while to actually start up. So my emulator should be emulating the actual speed it should be running when I actually get it running on my actual physical computer. So because I specified charset.base, it runs it as soon as it comes up. So if I type list now, and that's the program, the basic program. But you can also run a program by typing run. You can either load the program by typing load and then the file name, or actually load and run it by typing run. And I'll type my my Blitz game. If I actually no, because I'll actually load it, because I'll list it out first to show how big it is. So if I list it, so the game is not very big at all. That's the size of it. So that's all it is. but I'll end this video by actually running and playing my Blitz program. So you'll have seen this before in previous videos, because this is the program which I just convert. It's the same program which is running on all the computers that I demonstrate it on, and I just have to make a few minor changes depending on the actual basic version which is actually running it. It doesn't take many changes, and I'll just finish this video by playing this to the end, and I'll bound to crash into a building eventually.